Welcome back to Stats Talk. Thanks for joining us. Sorry, I can't talk like that. Couldn't do it. Anyway, moving on. So here we go. We're going to wrap up difference of proportions, significance tests, and then we'll launch into some other fun stuff Wednesday. But anyway, doesn't matter. So according to phys.org, Black and Hispanic females are underrepresented in STEM programs compared to non-STEM programs. A certain university would like to see if this is true for their student population. We took a random sample of 300 students and found that 12 or STEM students and 12 were Black or Hispanic. That seems significant. There's that. In fact, let's call that P1. So remember, life's better with sound effects. And then a separate random sample of 500 non-STEM students at 75. We'll call that P2. Don't worry, that's probably the last writing you're going to see from me today. Do the data provide convincing evidence that Black and Hispanic females are underrepresented in STEM programs? Use a 5% significance level. So first of all, the parameter. Actually, you know what? Do this. Pause. And I would say sketch out this entire problem. You know how to do most of this. Actually, you probably know how to do all of it, to be honest. There might be one or two little tweaks. But, go ahead and sketch it out. I wouldn't run, like, big, deep things, but jot down formulas, parameters you should be able to fall out, naming the procedure you should be able to do, conditions check, all this other stuff you should be able to kick out. So again, take 5 or 10 minutes, sketch it out, come on back. Hey, you came back. Thanks. Anyway, parameter, bam, P1 minus P2. The true difference in proportions of Black and Hispanic females in STEM and non-STEM programs. P1 is going to be the STEM programs. P2 is going to be the non-STEM programs. If you do the math here, the 12 divided by 300 and the 75 divided by 500, you get a difference of a negative 0.11, so 11% difference. And again, depending upon how you do this, you could swap the P's, doesn't matter. Generally, first group versus second group. Hypotheses here, you got 2. You should have come up with the null hypothesis saying that there is no difference. So the difference between the two is going to be 0. The alternative hypothesis is that P1 minus P2 is going to be less than 0. And it would seem to be here, at least the data seems pretty significant. And significance level, alpha equals 0.5. Name the procedure. I know this will be a shock. Wait for it. 2 sample z-test for P1 minus P2. You can also say the difference of proportions. Kind of actually like that better, to be honest. 2 sample z-test for P1 minus P2. Why z-test? Because we're doing proportions. Is it random? It says random sample of 300, random sample of 500. They said it, we'll take it. So randomness, 10% rule. Remember 10% rule. Make sure that all the individuals who were chosen, it was independent. They weren't going to affect each other. We have 300 is less than 1/10 of all the STEM students. You know what? I'm going to do this. Come on. Oh, I locked it. There, fixed it. Just because of the typing. So it's going to be, 1/10 of all STEM students, 500 of all non-STEM students. It wouldn't be beyond the realm. Well, you figure it's either you're STEM or you're not. It says a university. Universities tend to be larger, so that means that you'd have at least 3,000 STEM students, 5,000 non-STEM students, so 8,000 total. I think you'd be fine with that. And the large counts, which talks about normality. P-values, remember, whoa, wrong. When you accidentally delete a whole page, it's not your best move. And then obviously you're going to go through and you're going to do all of the percentages. So everything there's bigger than 10. So we're random, we're independent, we've got normalcy. Sounds like we're ready to go. All right, this is the place where you will probably have done pretty much the right thing, but there's a small tweak that we're going to have to talk about. So first of all, your mean. We are going to assume ideally, that there is no difference. This proportion of Black and Hispanic females who are in the STEM career should be the same. STEM program should be the same as non-STEM programs. So for the standard deviation for here, so again, so we're going to assume 0, 0. Standard deviation, I'm going to assume that you probably did something like this, which would be mostly correct. The difference, however, is this. If everything was the same, why would we have to have the standard deviation separate? You wouldn't. It's if everything was the same, you'd have basically the same thing. And so what they end up doing here then is that they basically combine the two. And so you're going to take the proportion. Now the question is, what are you going to count for P? Well, the proportion that you're going to do is this. You're going to say, well, if everything's going to be the same, then what you're going to see between the two should be the same. So we're going to say, all right, well, if everything's the same, we should be getting, in this case, about 11%. So we're going to take the total number of people who fit the criteria. So up here at the top, 12 and 75, these are Black and Hispanic females in any career, any program at the university. These are the 800 people who were chosen from. So the proportion should be 0.109. And that's what we're going to use for the standard deviation. So over here for our standard deviation, that's what we're going to go through and do. So we calculate all of that out. Dun, 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 dun. And that actually turns out to be right around 0.023. Our difference was 11, so we're going to be down over here. So we're going to say, how big is this area? How likely, by chance, that we're seeing this 0.11 difference when we have a mean of 0, we have a standard deviation of 0.023. So again, general formula hasn't changed. The stats test is right there. The specific formula apparently, anyway, the specific formula apparently I forgot to write down when I was prepping this. My apologies. I'll show you the work and then I'll talk you through what the specific formula will be. Your z-score is going to be, so it's the observed differences here. So the P1 hat, P minus, P2 hat, minus P1 hat, P2 hat. So in this case here, a difference of 11%, negative 11%, minus 0. Down here is your standard deviation that we're pulling from up here. Again, this is our combined standard deviation because since we're finding this up here of 0, then we're going to say, okay, well, if the proportions shouldn't be different between the two, we're going to lump everybody together and make it one big group. Basically, we surveyed 800 people, 87 of them were Black Latino females. So you do all this math, blah, 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 blah. You get a z-score of a negative 4.838. You already kind of see where this is going, I'm sure. So our test statistic turns out to be that, and our p-value is extremely small, statistically 0, basically. So that'd be 6/10 millionths. Yeah, that's pretty small. All right. So we know that that's basically, there's no way this could happen. So here's how we're going to write this out. It's going to sound pretty familiar, but let's go ahead and talk about it. Assuming that there is no difference between in the proportions of Black and Hispanic females in the STEM and non-STEM programs, there is a 0.0000006 probability of getting a difference of the sample proportions of negative 0.11 or farther. Gosh, he's purely by chance. We reject the null hypothesis as this is statistically significant. We conclude that Black and Hispanic females are underrepresented. This is why you proofread, people. Actually, this is why you have somebody else proofread your stuff. Life tip. Not going to charge you extra for that. In STEM programs at this university. Yeah, maybe I should put a secret word in here. Sorry, I digress. So again, you're making the assumption, you're going to state the null hypothesis. Nothing's different between the two. This is the probability that what we saw could happen given the null hypothesis, given the original statement. and then we say we reject or we fail to reject, and then because of that we conclude that Black and Hispanic females are underrepresented, etc., etc., etc. All right. Important ideas. And then you guys can go through and do the check your understanding run. Important idea number 1, hypotheses. Boom. So again, null hypothesis, you're subtracting the 2 and you're getting 0. The alternative hypothesis is that you're subtracting the 2 and, depending upon the situation, just like everything else we've always done, that you can either be greater than 0, less than 0, or not equal to 0. So you can't have two tails in this. Read carefully, people. First of all, PC hat. The little c there is proportions combined. So again, remember that happens if I have an arrow tool. Should use it. See, that's an arrow. So again, remember this happens, the proportions combined will only happen when this is equal to 0. Your means, they're supposed to be p-hats. They're really ugly p-hats. Sorry about that. So anyway, the mean of the difference of the two p-hats, we're going to assume is the same as the assumed proportions that we want in the population. Your picture looks like this. You got your normal distribution curve, mean of 0, because again, that's what we're assuming is going to happen, and then the standard deviation for this too. And then the standard deviation for these two wonderful things is, again, since P is the combined proportions, actually I forgot to do that. I am in rare form today. So P sub C Oh, I don't want it small. It's amazing what happens when you can pause the recording. So anyway, so the probability or the proportion of combined is the sum of the successes in both groups divided by the two group sizes, N1 and N2. Remember, basically, you're combining into one giant survey. That's what we're going to use for P sub C. So that's the basics. Again, something that you should have been like, hey, this all makes sense. The only difference right here is actually this little, the combined proportions part, which again, same general formulas, you're just combining everything together because you're assuming if, since our null hypothesis over here is 0, then you're going to treat both groups, or at least the standard deviation for that, putting both groups together so it's like one big survey of stuff. So give it a shot, try out some problems. We'll self-assess tomorrow and then pull it back together the next day after that, and we'll start playing around with what happens when we start doing with means. Talk to you soon. Hang in there. Enjoy yourself. Have a statistical day. Oh, and before I forget, subscribe, like, hit the notification button. What else do they tell you to do? Whatever they tell you to do in the YouTube videos. See you in a few.